Hello everyone, welcome to this new TouchDesigner tutorial. And in this tutorial we're gonna build the next chapter of the Generative Design series, that is the P223, and it's called Shapes from Agents. So we're gonna end with a network like this, and for this time this sketch could be done with only stops, only operators, no coding, but this will not be the same for the next chapters, but because, because there are some limitations of using this, but we're gonna take advantage of using only operators to make this network. So I'm gonna put this aside. And I'm gonna open a new one. So yeah, we're gonna start. This is the code for processing. So first we're gonna build the shape and the render network so we can visualize what we are doing. So we're gonna add a circle sub, and this circle sub will be connected to a null for now. And now we can add a geometry, a camera, a constant material, and the render top. Oops, render. And for now, we're gonna use the transform to add the background. Our background will be white. We turn on the comp over background color, and finally we add a null. This null we rename it to BG, and we split our view in two, and on this right side we select panel, we go up a level, and on look we select PG, so we can now visualize our figure. So here this sketch takes the full size of the display width and display height, so we can interpret it here as 920 by 1280, maybe. Oh, sorry, 1080. Okay, that's it. And we need to have the panel with that size, but our render will remain 1280 by 720 because we are with the non-commercial license, but our space will be working at full resolution, so that's good. And yeah, so first we're gonna declare our parameters we need, that are these ones, or variables, that is form resolution, the number of points that this circle has, the step size, that is the amount of noise that will have this distortion of the of the shape. And this one is not used in this code. I don't know why it's declared here, so we're gonna avoid it. And the init radius. Okay, and yeah, that's it for now. We also need to declare mouse X, mouse Y. We're gonna use the mouse press, so we need to declare also the click of the mouse. And we also need to use the key 2 and 1 to change the mode of the shape. So I'm gonna open this, yeah, a second, and you can see that it follows our mouse. If we are with a velocity, it has the 0.01 the velocity we have dragging this mouse. And when we make click, it has the newest position of the mouse and it starts from 0. The shape starts at a circle, and if we click 2, then the shape is filled now and have a noisy trail. And also if we hit backspace, it cleans the feedback of the screen. Okay, so yeah, we're gonna make this. So here we're gonna use a constant chop, and the first name will be form resolution, that is equal to 15. Then the second one is step size, that is equal to 2. And finally we have init radius equal to 150. Yeah, so the next thing is to use a panel, and here we're gonna select the select, that is the click, and inside U and inside V, here will be equal to we can rename it to click and mouse X and mouse Y. Yeah, so here then we're gonna add a select, because we need to separate these two, or we can also yeah, we can separate or do it in the same one. It's the same, but for now we're gonna separate this click, and then we add another select, and here will be equal to mouse X and mouse Y. Then we need to convert this normalized value to the full size of the height and width, and we can do this using math. The first math will be equal to from 0 to 1 and to 0 to parent dot width. And on the command page, on the scope, we only select mouse X, and we add another math that will be 0 to parent dot height, and this will be only applied to mouse Y. Then we select both of them, go to the OP page, and the integer we select around, so we have integer values of our coordinates. Okay, so yeah, that's it for this. And also only we need the keyword in to select the mode, so we're gonna use the 1 and 2 key. From here we add a logic, and this logic will be a radio button. Then we add a fan. Fan. We change the operation to fan in, and we last add a rename to rename the channel to field. And lastly, we use a merge, and we merge all of our channels. And finally we add a null, and this null we can rename it to params. Okay, yeah, or maybe this will be variables, bars. Okay, we can make this view, so we can have it here to make the exports more easy. We're gonna fix the camera. We change here to view orthographic, the ortho origin bottom left, and the ortho width raster, it's equal to parent dot height. Oops, parent dot width. So here we can see the shape because it has a radius of 1, and this is yeah. So we're gonna first export this init radius to the radius here, and now we can see the shape. Also, we change the type to non-obscure, and this form resolution will be the divisions here. And yeah, that's it for now. So I think the next thing we can do before doing the feedbacks is making the color, so we will have a better way to see what we are doing. So for the colors, we're gonna use constant, and I'm gonna explain why. Because first, the first color will be 0 and 50 with alpha, and this is because it's only the outline of the shape. And when we are filled, then we will have the full shape with its color, and will be a random value from 0 to 255. That will be a random value from black to white. Okay, so yeah, that's it. So here this will be 1 by 1. The pixel format 32-bit float mono, and the color will be 0. And then here we can connect a noise. This noise will be random because it's a random value. The output will be only noise, and the pixel format also 32-bit float mono. And we can use the apps time second to change these values. Just let me see, random GPU, sorry. Yeah, that's it. So it's changing the color randomly. Then we add a switch, and this switch will be this index parameter will be this field variable. So if we click 2, it will change. If we click 1, it will remain at black. Null. And we export this null to this constant. So now if we change it and we drag this constant to the material on the geometry, now we are good. Okay, so also to have the outline, we need to add here between the circle and the null this operator that is the curve, and what it does is it deletes the surface and only leaves the outline. And so we can do a switch here, and we connected the full one here. So if we are at 1, it will be black outline, and if we are 2, oops, it will be this full shape with the surface changing the color. Okay, so lastly, for the color, here we need to change the alpha, because here we have an alpha of 50 when the shape is only the outline, and a full alpha when the shape is complete. So we're gonna use Python here that will be 255 divided by 255, that is equal to 1, but we leave it like that because of this 255 here. and this will be equal to that value if op bars and the variable fill it's it's 1. If not, will be 50 divided by 55. And we need to go to the common page and turn on the blending transparency. So now you can see the difference when we change this fill and this. Yeah. Okay, so we're almost there because only we need to work now with the feedbacks. So yeah, the first feedback we need to make is the position. As you can see here, we have the flooring towards node position and calculate, sorry, flooring towards mouse position and calculate the new points. So these are two feedback loops, and we're gonna start with we can start with any of those. Maybe this will be helpful first. So here you can see that we have our initial form, and we add to this feedback a random step size, a random value, so it can deform the shape. So the way to do this is using first we're gonna convert this circle to chop data, and from this we're gonna make the feedback, and then we're gonna return this to sub data, and we're gonna see the shape increasing and deforming. So oops, after this I'm gonna add a noise. This noise needs to be random, and we have here a warning that is that the noise is not affected by this, but we don't care because we only need the values we want. And also here on the amplitude we drag the step size, so now have values from -2 to 2. That's good. We go to the channel page and select change to TX and TY because we need those two values. And yeah, we're almost there. We can add the feedback chop. And yeah, the feedback here, it has two inputs. That the first input is the input that is making the loop, and the first input are the initial conditions. When we hit reset, this will be the first value, and then it starts doing the loop. So the initial conditions will be always this circle size, circle shape, because that's how it starts, and starts deforming after having this adding of this noise. So to make that, we need to use a math, and we're gonna add combine chops add, and we need to select channel match by channel name. So here we can see anything because we don't have the feedback that is doing. We can drag it. We need to use a select, and then this math will be dragged to this select, and we need to verify that we make these steps good, because if something is not equal, the feedback loop can can be very infinite and will crash the software. So we need to verify that we are good. So I'm gonna add this here, and I'm gonna reset, And now you can see that it starts adding something. It starts deforming these values. So we can see it if we only make this attach a null at the end, and this null will be dragged to this chop to sop. We'll reconnect this, yeah, and we drag this to that place. And now you can see it here, but it's extreme big. So when we click the screen here, happen two things. The first thing is that the shapes goes back to the original form, original point position, and also it will follow the actual position of the mouse. But for now we only gonna reset so we can see the shape increasing. And don't forget to change here the seed to uptime dot seconds, so it's always a random value every time the feedback loop is done. So yeah, I think that's it for this first part of the feedback. That is the feedback of the shape. You can see that every time we click, yeah, it's happening, the deformation and from the original shape. So the next thing here, if we go back to the, whoops, I think I closed it. Yeah, wait a second, please. I'm gonna open again just to explain you what we need to do in the chops. So yeah, it's here. So the next thing, we did this one, the calculate new points, that is the position of the point plus equal random step size and that feedbacks loop, and we add now at the new position the random and again and again and again, and that's why we use this feedback. And the thing is almost the same for the center of the shape. Here we're gonna use this, so we're gonna add to the center, to the feedback, we're gonna add the position, the actual position of the mouse minus this value multiplied by 0.01, and that will be for both channels. So yeah, we're gonna do that. I'm gonna make some space, and first we're gonna use a select. This select will select the feedback, and this select will select the mouse X position and mouse Y. So we're gonna drag these bars and we select here mouse X, mouse Y. Then we need to add the feedback, and this will be on the initial conditions, because every time we click, I'm gonna put this on the reset, will be at the position of the mouse. Okay, so yeah, that's it. Then we need to make the operation, because we have feedback and the mouse Y, and now the operation is mouse X minus the center, that is this one. And here also we can use this rename, because if we don't rename, when we click the reset, it will have these names and the feedback will be wrong. So always will be renamed to center X and center Y, because this is after the feedback. Okay, so now we can use math from here, and because we need to subtract to these values this center. Okay, so I'm gonna put this here, check that these connectors are equals as this, and on combine shapes we add we change to subtract, and on multi-add we multiply by 0.01. And yeah, we're almost there. We only need to add this value to the feedback because we did this, and this is this operation, but we need to add to this value this value. So here we're gonna use math, and here we're gonna use add. And yeah, that's it. We only need to check that we are good with the settings, because if not, the feedback loop can crash, and yeah, will crash the software and all our work will be gone. So I think that it's okay. Okay, yeah, that's it. So we can now drag this, because this is doing the full feedback, to here, and finally connect this to here, and yeah, we have our feedback working good. You can see that if we move the mouse, it follows it, but we will see it in a second because we need to add here a null. And after this, we're gonna use here, to this shape, to this position, we're gonna move to the center, and that operation of the processing code is here. The new shape is the actual position plus the center, this center. So yeah, that's why we need to use a transform XYZ. This is the same as the transform for the subs and the tops, and we only drag this center X to here and center Y to here, and yeah, now it's following our mouse position. So yeah, we're almost there. We only need to make the feedback for the trail, and you know that's very easy because we only need to use feedback and an over connected, yeah, and we drag it to the feedback, and now we are there. We have our shape. If we click fill, you can see that now it's changing. If we click here, the shape is reset and starts from the actual position of the mouse. And yeah, so you can start playing with these parameters, with this, the resolution, the step size, the radius, and yeah, work with that. Finally, we only need to add a keyboard in to make this reset, and this reset is done with the backspace. So remember, when we're using backspace, don't forget to make the operation inside the panel, because if you do it in the network, you probably will delete the last selected operator you have. So do it inside the panel. I'm gonna add here and backspace. Click one, and yeah, that's the tutorial for this chapter. I hope you enjoyed and learned how to use the feedback chop. And also, I just want to show you that the file that will be available for my patrons will have the network of the chops, the network of the tops, and the script. This is the most optimized in terms of having less operators, and this is the more optimized in terms of computation because it's done in the GPU. But I think you can learn how to achieve the same result with different families of operators. So yeah, that's it. I want to thank to all my patrons. Thank you for your support, your patience, uh, and I will see you on the next tutorial. Goodbye.